So let's build an analytic application with ClickHouse together. What do we need? And what do we need it for? There could be multiple reasons. One of the reasons is just for testing, to test our cloud service, if it works well on unusual scenarios. Another reason is to make our internal company contest. So I have announced a contest inside our company. So everyone in every department have to try, experiment with some data, and build a nice application and receive a prize. It ended up in the following way. I was the only participant of this contest, and I did not receive any prize. But it was still worth it, because I always like to play with ClickHouse and have fun. So what we will need? We will need some interesting idea, a nice data set, and a nice way to analyze and visualize this data set. And where to get our data set from? There are many public data sets, like from social networks. For example, for Reddit, you have a website not affiliated with Reddit, but containing a data dump with about 30 billion of comments, messages. And the same exists for Twitter. It is definitely of questionable legality. But if you want to experiment, just download this data, go for it, try it, and you will get some insights. Stack Overflow provides official data dumps of all of their comments, all of their answers. There are data from the internet. For example, Common Crawl contains a few hundred gigabytes of HTML pages. And why don't load a few hundred gigabytes into ClickHouse when I have a few hundred, terabytes? When I have a few hundred terabytes or petabytes, the first thing I do is upload all of this into ClickHouse. There is data from a public sector in the United States, like from the state of New York. But if you want to use them, please hurry up, because who knows, maybe 1 week later, this data will not be available. So please download it, upload into ClickHouse to save it for the humanity before it will be destroyed. There are dumps from Wikipedia, from OpenStreetMap, data from temperature and climate sensors, a lot of data sets. And I will use one data set named ADS-B. What is it? It is automatic dependent surveillance broadcast. Is it clearer? No? So this data is from airplanes. And every airplane, and not only airplane, every flying thing like a helicopter, a drone, some drones, whatever, gliders, they have transponders. And transponders broadcast radio signal, unencrypted. And you can basically receive this radio signal from a thin air. You can have a software-defined radio, and it will read the signals from all airplanes, helicopters, etc., from an area like 100 kilometers. And you will be able to analyze this data. And it contains a lot of telemetry, like coordinates of each airplane, velocity, roll angle, this angle, another angle, everything. Aircraft type, air company, owner of the aircraft, you will see its usage later. So it is easy to collect. But what if you want to collect it not only from 100 kilometers radius, but from all the world? By the way, if you do it, it will look like this. It is not my website, it is Flight Radar 24, just one of examples of application of this data. But OK, I want the data from all the world inside ClickHouse. And there are services named ADSB data exchanges. They work in the following way. You provide your own data that you collected, and in the exchange, you receive this data from all other enthusiasts across all the world. And there are plenty of ADSB exchanges. Let me list them. ADSB.fi, ADSB.1. So phi is probably from Finland. One is, I don't know what, ADSB.lol. I don't know why it is named this way. ADSB Hub, Airplanes Live, OpenFlights.org, FlightAware.com, ADSBExchange.com, FlightRadar24, OpenSky Network. Plenty of data exchanges. And I have to figure out which of them provide this data, hopefully for free, for redistribution, whatever. And the most convenient was ADSB.lol. They provide these files on GitHub. Each file is about 1.5 gigabytes, and the total size is like 10 terabytes. So the next thing I did is just downloaded all of these files and set up a script to download them continuously. So it was the easy part. Download all the data, insert into ClickHouse. Let's just in case check how to insert and what the data looks like. Each file contains a lot of smaller files, JSON files produced by some tool. And these JSON files contain some metadata about aircrafts. So for example, TAT76, it is ATR 72600, a type of airplane. Timestamp and a list of traces. And every trace is a coordinate, altitude, speed, vertical speed, and many other fields. So we will split this into two JSON files and then join them together. In this example, what I have decided to make it just a single line shell script. This is a single line shell script. It works with ClickHouse Local, which is a full ClickHouse engine available as a command line application. And inside this ClickHouse Local application, I have a SQL query, insert select. And insert, it will be not just insert into a table, it is insert into function. And the function is remote secure with the address, the endpoint of ClickHouse Cloud. So I will insert everything into ClickHouse Cloud using this script. And as a select, I use two table functions. Both of them is the file table function. They will read this JSON in JSON lines format. One looks like arrays, so it is named JSON compact. Another is a list of objects, JSON each row. And I do cross product of these data sets and then do some post-processing of the data. So it's pretty easy. Just a single line, and the data will be in ClickHouse. The table that I created in ClickHouse Cloud looks like this. It has all the usual fields, some timestamp, date, some enumerations, like here, aircraft category, aircraft emergency. For example, if something happened, like the fuel is almost no fuel, it will broadcast this emergency. And there are some interesting parts. So we have coordinates, latitude and longitude, float 64. But also, I translate them into two materialized columns, named Mercator X and Mercator Y. What do they represent? There is a geographical projection named Mercator projection, and they are used in every web maps, like Google Maps, OpenStreetMap. They just map all coordinates into a square. And here is the formula how to do it. It contains some logarithm, tangents, pi, and another pi. And trust me, it works. And also, I use the data type uint32 because it will just represent a grid inside this Mercator projection, integer grid. And I have two indexes of type min-max on one coordinate and on another coordinate. So hopefully, when I just draw a square on a map, these indexes will be able to locate this data. But the most interesting part is here. How do I order this table? Do you see it? Order by. So it is a tuple. The second element is time, no surprise. But the first element is a more than encode function of these two coordinates, x and y. Who knows what it is? Just one person? Who else? OK, let me explain. So how should I order this data set? I can order it by just one coordinate, x, and then by coordinate, y. And then I will have this order like x first order. Let's say it this way, or vice versa. It will be ordered like scan lines. I can order it in a different way, and the order will be like this. But if I will draw a square and want to locate the data inside a square on a map, none of these indexes will work as well as they could, because they will select just like a full stripe on a map instead of just a square. The Morton encode function is very interesting. It takes two numbers and mixes them together. It takes the most significant bit of the first number, then the most significant bit of the second number, then the second significant bit of the first number, etc. And you can imagine it like a quad tree. It will split the data by quadrants, like this. And inside each quadrant, it will again split the data by quadrants. And it is named a space-filling curve. Sounds pretty complicated, right? But don't worry, I will show you it on a demo. So after a day, I downloaded 50 billion records, around 1.6 terabytes compressed. By the way, today it is 150 billion records and about 5 terabytes of data. It has grown since I created this service. Let's do something beautiful with this data, and let's visualize it, aggregate and generate reports. So let's go straight ahead to the demo. Here is a website I created, and let's see how it will work. OK, it shows you something. Is it beautiful? It is. What is it? The colors represent the altitude and velocity of an airplane, and the transparency is the number of traces. And you know, it is generated, so this map shows some tiles, and each tile is generated by a SQL query. This is a SQL query in ClickHouse. And this is a parameterized query. And it generates 1 million of pixels, returns these 1 million pixels in the browser, and the browser renders these pixels. So each pixel on a map is generated in real time by ClickHouse. Let's take a look more closely. So what it is? Absolutely, it is the city. And what are these red balls, red whatever points? Exactly. And how many airports are in Bay Area? No, not 30, probably more. And you know, I have many query examples. For example, I can filter only by light aircrafts. So let's zoom in. And now, instead of all aircrafts, I will press on light aircrafts. And now you see how many airports are in Bay Area, and probably even more. Let's find an airport named Sequel. There is one in San Carlos. It is somewhere. I see San Carlos. And this is a Sequel airport. And I can even generate a report. Here is a button, and I locate an area. And now, in real time, with a query to ClickHouse, I have all airplanes ever landed or ever flew above the Sequel airport. And there are mostly small airplanes. And I can even filter by some of them, like, let's find the most unusual one. Cessna 172 is not unusual. So which airplane from the list do you want to select? Maybe this one? Let's take a look. And now we have the report only on this airplane, but let's zoom out and see how many are in different parts of the world. Maybe there are some in Europe. There are some in Los Angeles, in Las Vegas. Yeah, plenty of interesting stuff. And what changed? This. It just added a condition to a query. So we have an aircraft category and the type. Okay, there are plenty of reports. For example, we can select only A380s. And here are all A380s. They can land in San Francisco and Los Angeles. I can spend a lot of time on this map. It is so interesting. It is so nice. And I can find some unusual stuff. For example, in France, let's zoom into France. Here it is. And you can see that near Toulouse, this A380 fly on some unusual patterns. What could it be? Yeah, it is a factory, and they test them. Or another example, I can show military airplanes. And it just modifies the SQL query, adding a single condition. And we can see that, what we can see, let me check. This looks like an airbase with some training area. And it is a Cognac airbase in France. And I hope pilots don't drink cognac. But let's take a look what is in the United States. In the United States, a lot of interesting stuff. For example, this is Langley Air Base. They fly to the ocean, then do some circles and return. So, okay. Now let's go back and see how is it all possible. 150 billion records displayed in real time with each pixel comes from ClickHouse. And ClickHouse is just a database. It is not a GPU database, it is just a regular database. Let's take a look. So the first component is the REST API. ClickHouse server has embedded HTTP API. And if you query it from JavaScript, it is as easy as using the fetch API and query in the post method. Basically, these 3 lines is all you need to query ClickHouse from an HTML page. If you have some advanced usage, you can use the TypeScript driver. If you have any other language, Go, Python, Rust, maybe, Erlang, Elixir, Haskell, we have drivers for each of them. Another component is the support for parameterized queries. And this is slightly different to other databases. So in many other databases, when you have substitution, it is just a question mark. Instead, in ClickHouse, substitutions are type safe. So here you can see two substitutions of type uint16 and one substitution which is even not a value, but the table name. It has a type identifier. And these parameterized queries can be a basis, can be used for parameterized views. So you can do something like this: create a view as parameterized query and then call it as a table function. It is pretty nice. I did not see it in other databases. Yet another component, materialized views. So I used one trick to speed up my service. It queries not a single table, but 3 different tables. One table contains full data with 150 billion records. Another contains just 10% sample from it, 15 billion records. And another contains just a single percent, 1.5 billion records. So I do this. I query the first, I query the sampled data first, 1%, then 10%, then 100%. And the service is responsive. And to manage these tables, I use materialized views. Materialized views act as triggers to process your data while data is inserted. So whenever I insert into the biggest table, it will also insert a 10% sample into another table and 1% sample into yet another table. But you can do more advanced stuff like incremental aggregation, incremental filtering, indexing data. Whatever you want to process in real time, you can do almost whenever you can do with materialized views. Role-based access control. So I have made this service and I put it directly to the internet. So ClickHouse server is exposed to the internet. You can even connect to it with ClickHouse client. But you can do only read-only queries. I created a user with read-only equals to 1 and a few more settings. I granted select only 2 specified tables, and ClickHouse has support for usual role-based access control. It has support for column-level security, row-level security. Probably the most advanced implementation of access control in any open source database. Maybe except Postgres, but I don't think that Postgres has something more advanced. Quotas. I also don't want my service to be overloaded by a single user. So I created quotas by IP address, and for every IP address, I count the number of queries, the number of records that are being read. And if you use the service too much, it will just refuse. It will say, OK, please wait 1 hour, and you will be able to continue. And it gives just a bit of DOS protection. Another component, indexes on expressions. So here I created a materialized column with a functional expression, and it is pretty complex. And I created indexes on this column. Actually, I could just specify this expression here, but I also want to materialize this column. And the primary key is also functional, calculated on an expression. ClickHouse has a different flavor of SQL than many of databases. I would say your dad's databases, like Postgres, MySQL, your grandma databases. ClickHouse is way more modern. Whenever you have CTE, common table expressions, you can also specify aliases, like here. And you can reuse one alias in any other place in any other expression. Like here or here, I create one alias that is created on top of two other aliases defined above. It sounds very natural, and you will get used to it immediately. And you will be surprised that other databases don't have this feature. ClickHouse has table query parameters, and let me show you another interesting feature. So this is also extension to the SQL with fill modifier for order by. It will automatically fill the missing values in the ordering. So I want to generate pictures, and every picture should contain exactly 1,048,576 pixels. And if there is no data for some of these pixels, I want to return 0. And this section with fill will do it. You can even specify some expressions how to fill this data. It supports interpolation of the data. It's pretty nice for report generation. ClickHouse has support for almost every data format you can imagine. Text formats, TSV, CSV, structured, semi-structured, JSON, binary formats, raw binary, Parquet, ORC, Arrow, native, Avro, Protobuf, message pack. Do you know any format that ClickHouse doesn't support today? No? Okay, we have everything. What? Excel. Ah. You know, actually, you can ask Excel to save in CSV. And problem solved. And also, if you use whatever, Office 365 or Google Docs, you can use their HTTP API, and it will return CSV for you. But it's a good idea. Why don't implement Microsoft Excel? Maybe PDF. Why don't implement PDF? Maybe read pictures with AI. Okay. ClickHouse does compression out of the box. And this is not only about data at rest, not only about the storage. So the storage is efficient because it is compressed, but no surprise here. It can also read any data on any external data in any format, including just file level compression like gzip, LZ4, ZSTD, or even archives like zip with multiple files, 7z, tar, targz, whatever, tarball. Network traffic is also compressed. It has support for HTTP compression. And when I created a service, I was surprised because, so ClickHouse returns these pixels. And initially I thought I have to use a PNG format so it will be compressed, or JPEG, or something else. But instead I did this. I just returned pixels compressed with ZSTD in HTTP. And I was surprised that ZSTD is more efficient than PNG. Actually, it is not so surprising, but interesting fact. Infinite storage. Because ClickHouse has support for local storage, but also object storage on AWS S3, Azure Blob Storage, GCS. And it can use hybrid storage. And it can query data lakes such as Iceberg. So probably Netflix will be happy using ClickHouse for Iceberg. And if not, tell me, and I will make you happy. Parallel and distributed queries. Every query is obviously, as expected, distributed, processed by all CPU cores, all machines on the cluster, so it is fast. Query result cache. Again, one trick. I enabled query result cache on this service. Actually, it is not always used because the number of these different queries is almost infinite. But when you open it by default, most of the results will be from the query cache. And what is also interesting, ClickHouse is not only a server. It is also ClickHouse Local, which is a command line tool. And this command line tool, it is like a full-featured application, a Swiss Army knife, whatever, for data processing. And it is just a single binary. You can take it anywhere. You can use it in AWS Lambda, in ECS, any places you can even imagine. With ClickHouse Local, you can pre-process data. You can analyze it on the fly. There are many similar tools listed here, but trust me, ClickHouse is the best. The most feature complete, the fastest, the best user experience, easy to install. If you did not try it, use it today. What else? So, ClickHouse is the best database management system for analytic applications. It is fast, scalable, resource efficient, easy to use. It is nice to work with, robust, reliable, has everything included. And let me say, friends, tell friends to use ClickHouse. So tell all your friends to use ClickHouse. And they will thank you for that. OK, that's it for me. Thank you. First of all, let's take a look at the query. The query contains some tail numbers. These numbers are on the tail of the airplane. They are also named registration numbers. This is not necessarily Elon Musk personally, but I just asked Google, what are the personal jets of Elon Musk? And here is the list, 4 of them. And it looks plausible. So this is Bay Area. We can even look at which, no, it is Los Angeles, but also we have Bay Area. This is somewhere in Texas. Probably there is a factory in Texas, whatever, near Mexico border. What? Ah, interesting, yeah. Austin, Texas, Miami, New York. Interesting, by the way, which airport in New York Elon Musk likes? Probably not JFK. What do you think? New York? Yeah, let's take a look. What do we have here? Actually, no. There is no New York. There is Teterboro Airport. Probably a very special one. Sometimes he flies in Europe. And you know, we can even check when exactly did he use this airport. In 2022 and in 2023. And here are his airplanes. I think they should not own these jets. He should rent them, because now we can look at the history of each of them. OK, any more questions? Air balloons on the screen. They have interesting path. Let's take a look. So this is not a hot air balloon, and this is also not. But sometimes, what do we have? For example, what is HBEL 635? Aerostar flight operations. Interesting. Or let's take a look at gliders, where gliders can fly freely, in which places. Yeah, pretty interesting. If we look at Europe, you can see that gliders are popular in some countries like Germany, Netherlands, but not in France for some reason. Okay, please. Most likely, yeah. Yes, but here I want to go into precision of a single pixel. I don't want even to aggregate by hexagons. But you know what? ClickHouse has support for H3 embedded. There you go. Yeah, you can use it. Please. Yeah, now that SQL 23. Yeah, interesting. An extension to SQL, name it property graph language for graph databases. It is a possibility, but we did not see a lot of demand, to be honest. If you have some scenario requiring this feature, we should consider it, but it is not very popular. Maybe we should have it in ClickHouse, but I see you expect that we are like magicians who just add every good thing into the database. And often it is the case. Okay, please. I'm the most excited about the new JSON data type. It is currently in beta. We want to promote it to production in the next release if we will not find any additional blockers. And so far, there are none. So most likely it will be production ready in 25.3. And it is a way to store and process semi-structured data, such as any semi-structured logs, API responses, as efficient as you have if you specify these columns manually. So it is a full columnar storage for semi-structured data. And I think it will be a game changer. Let me open it. We have made a benchmark for databases supporting JSON data type for analytics on top of JSON, the JSON data type. So we used a data set with 1 billion records. 1 billion is not a lot. It is from a social network named Blue Sky. The data is quite messy, but we loaded it into ClickHouse as is. And the results are here. ClickHouse is the first, but it does not surprise me. We just made all the best. So ClickHouse is the first as expected. But what is surprising that any other database, for example, Elasticsearch is 17 times slower. MongoDB is 1,500 times slower. DuckDB is 5,000 times slower. And Postgres is 10,000 times slower. And I would say that for many scenarios, you can only use ClickHouse. ClickHouse is the only solution. Yeah. We benchmark a list of queries. There are 5 queries. And these are typical analytical queries, like counting of events of different type, calculating aggregates on these events, filtering by fields in JSON. So what you typically have when you want to filter logs, These queries hopefully represent this scenario of observability on top of logs.